Hello everyone, I'm Jesse Mason, and in this edition of Teach Me, we determine the electric force between a proton and an electron for the Bohr model of the hydrogen atom. We're also going to determine the gravitational force between those two particles, compare the forces, and see how they match up. Okay, so first we start by drawing a picture. At the center of the Bohr model is a single proton, and orbiting this proton a fixed distance away is a much tinier electron. In fact, the proton is about 2,000 times the mass of the electron, which is why I'm going to draw the electron as a pale blue dot here. And it looks like our proton is a little uppity today. Get it? Uppity? Two up quirks? Anyways, the distance between the proton and the electron is referred to as the Bohr radius. The Bohr radius is equal to 0.529 angstroms, where 1 angstrom is 10 to the negative 10th meters, or 1/10 billionth of a meter. I'm also going to indicate that we're looking for the gravitational and electric forces between these two particles. And before we move on to the equation part of the problem, I think I'd like to point out an underappreciated fact about the atom, and that is that the atom is mostly just empty space. Consider a proton here. If that proton were the size of a grape, then its companion electron would be the size of, I don't know, a flea, and the entire atom would be the size of a football stadium. That's how much empty space is in the atom. Okay, on to the equation part of the problem. To determine the gravitational force, we're going to use Newton's universal law of gravitation. And we're going to circumvent the vector aspect of this problem by noting that gravitation, as far as we can tell, is always an attractive phenomenon. So new log tells us that the gravitational force is equal to g, the gravitational constant, times m1, the mass of body 1, times m2, the mass of body 2, divided by the radial distance between those two bodies squared. In physics, an equation that has a quantity that's inversely proportional to the square of the distance is called an inverse square law. New log is an inverse square law. So, gathering our constants from a reliable source, like a ridiculously expensive textbook or Wikipedia, whichever you prefer, we have gravitational force is equal to 6.673 times 10 to the negative 11th Newton meters squared per kilogram squared, times the mass of a proton, 1.673 times 10 to the negative 27th kilograms, times the mass of an electron, 9.11 times 10 to the negative 31st kilograms, divided by the Bohr radius, 0.529 times 10 to the negative 10th meters squared. Plugging this into a trusty TI-83 Plus, I get the gravitational force is equal to 3.63 times 10 to the negative 47th newtons. Box that up. And next we'll use Coulomb's law to determine the electric force between the two particles. Coulomb's law states that the electric force is equal to K, Coulomb's constant, times Q1, the charge on body 1, times Q2, the charge on body 2, divided by r squared, the radial distance between those two bodies. Again, we have a factor of r squared in the denominator, which indicates that Coulomb's law is an inverse square law, just like new log. Okay, so we have Fe is equal to 8.99 times 10 to the 9th, that's a positive 9, Newton meters squared per Coulomb squared, times the charge of a proton, 1.602 times 10 to the negative 19th coulombs, times the charge of an electron, negative that same value, divided by 0.529 times 10 to the negative 10th meters squared. So we get the electric force is equal to negative 8.24 times 10 to the negative 8th newtons. Negative? What does this negative sign mean? This negative sign tells us that it's an attractive force. If it were positive, it would be repulsive. You see, the electric force, unlike the gravitational force, can be either. Now, to compare these two forces, we're going to use a ratio of Fe to Fg. But before we do, we need to take absolute values because one of them's negative. When we do, we get 2.27 times 10 to the 39th. Leaping leptons, that is a big number. What does it mean? It means that the electric force is stronger than the gravitational force by about 2,000 trillion times. Think about that next time you get static cling. I'm Jesse Mason. I hope you found this video helpful, and until next time, happy learning.